These notes are solutions and solubility. Okay, there are three main types of solutions. You have a saturated solution. That means no more can dissolve. You get as much as you can possibly get in there. Unsaturated means you've got a little bit of solute in there, but it can actually dissolve more. And then you have supersaturated, which actually means that at a particular temperature, that solution is holding more dissolved solute than is normal. You achieve that by heating it up, dissolving the extra solute in it, and then cooling it down slowly. Okay. In fact, rock candy is made this way. It's a whole bunch of sugar is dissolved into water, okay, at a higher temperature, and then it's cooled. And then a seed crystal is put, well, actually it's a string put in there, and a seed crystal is put on that string, and all of a sudden all of that sugar will adhere to the string at that point in time. And in fact, you're going to have an extra credit project. It's going to be a rock candy extra credit project, and I'll talk to you about that in class. Okay, the ability of a solute to dissolve in a solvent at a given temperature is called solubility. Solubility is dependent on temperature and pressure, and we can use a solubility curve to gain a lot of information about the solubility of certain salts in a particular solvent. And at this point in time, you need to get out the solubility you need to get out the solubility curve that I gave you in class. Okay, this is an example of the solubility curve. It's almost the exact same one, it just has an extra curve on it, so just kind of ignore that. But the rest of it is exactly the same as the one I gave you in class. Okay, so we're going to use this one for all the rest of the problems in these notes. Okay, which salt is the most soluble at 40 degrees Celsius and which one is the least? So at this point in time, we've got to find 40 degrees Celsius, which is right here, down here. You do them at the bottom, because, okay, don't use the one up here. That's not 40 degrees Celsius. That's 40 grams. So we are going to look along this particular line right here. Now, as I said, your curve does not have the Ce2SO43. So we're going to ignore that. We're going to pretend that does not exist. Okay? Because on the curve I gave you, it's different. Okay, so which is the most soluble? That means the highest. Okay, the most soluble means it's the highest on the curve. Okay? And at that point in time, at 40 degrees Celsius, that is right here. NaNO3. So the most soluble is NaNO3. Now, the least soluble is down at the bottom. And at this point in time, it's this one. So it's KClO3. Okay? Okay, how many grams of KNO3 can be dissolved in 100 grams of water at 50 degrees Celsius? Once again, we're already dealing with 100 grams of water. That's what this whole thing is. So let's just make sure you know that it's 100 grams of water. Okay, we're going to find 50 degrees Celsius first, which is right here. And I'm going to go ahead and draw a line up it. You don't have to do this on yours because you're not going to want to mark it. But I can mark it on mine. Okay. And then I want KNO3. So KNO3 cross is right here. So when you bring that over, it's 80 grams. Okay? Hopefully you can figure that out. Now, when reading the curve for a particular solution, any amount of solute above the solute line is a supersaturated solution. Any amount of solute on the solute line is a saturated solution. And any amount of solute below the solute line is an unsaturated solution. And we'll go through a couple of problems so you can see what I mean. Okay, tell whether the following solutions are saturated, unsaturated, or supersaturated. Okay, we're going to look at the first one. You've got 30 grams of KClO3 at 70 degrees Celsius. So first I'm going to find 70 degrees Celsius, and then I'm going to put 30 grams. So I'm going to go up to here and here. Okay, this is what I'm talking about, right in that corner, right there. Now I'm going to look at the KClO3 line. This is not on the line, it's below the line, okay? So this is below. KClO3 line. So that means this is an unsaturated solution. So let me push this up. So this is unsaturated. Okay, now the next one, I'll use blue for the next one. 40 grams of NaCl at 80 degrees Celsius. So we're going to go 80 degrees, 40, and we're right here. Well, that's right on the line. So this one is going to be a saturated solution. See, it's right on that curve. This is the the NaCl line, which is kind of weird. Kind of goes down a little bit. Okay, actually here, this is the NaCl line right here. Okay, yeah, so it crosses right over it. Hopefully you can read all this when I'm done. Okay, next one is 140 grams of Ki at 10 degrees Celsius. So we're going to put 10 degrees and, oops, I'm going to have to move this down a little bit. Okay, we have 140 grams at 10 degrees Celsius. So it's right here. And that's right above the Ki line. So because it's right above the Ki line, this is a super saturated. And if you have any questions, just ask me in class tomorrow. I'll be glad to answer them. Now, most solubility curves are done in 100 grams of water. Sometimes you need to know how much of a particular salt can dissolve at a different amount of water at a particular temperature. And you can use proportions to calculate this amount. Okay, how many grams of NH4Cl can be dissolved in 250 grams of water at 80 degrees Celsius? Okay, in order to do this, we have to set up a proportion. So we're going to do the amount of the solute, which is our salt, over the amount of the solvent, which is the water. Okay, so let's move this up a little bit. Okay, so basically we know that we have 100 grams of water to start with, and we're looking for 250 grams. Okay, now we're looking for the amount in 250 grams, so we have to find the amount of, actually let's change this to NaCl. It makes it so much easier. I don't know why I wrote NH4Cl. Okay, so 80 degrees and NaCl is right here, and that's 40 grams. So X is 250 times 40 divided by 100. Just like in the gas laws, we're going to cross multiply. Okay, we're going to multiply those two and then divide by that last one. And when we do this, okay, so we do 40 times 250 by 100, and we get 100 grams. So it's 100 grams of NaCl. Okay? Okay, how many grams of KNO3 can be dissolved in 415 grams of water at 55 degrees Celsius? So once again, we're going to move this up a little bit, making sure I don't go above 55. Okay, so we have 55. So first thing we're going to do is write the 100 grams of water here, and the 415 grams of water here, and the X here. So we're going to look at 55 and KNO3. It's right here. So that's 90 grams. Okay. So then your X, you're going to cross multiply, is 415 times 90 divided by 100. Okay, so when we do this, 5 times 90 divided by 100 comes out a weird number, 373.5. We're going to say 374 grams. Okay? Last one. How many grams of solvent or water can 55 grams of NaCl at 80 degrees Celsius be dissolved in. Okay, so this time we're looking for the water. So we're going to still start out with our, our 100 grams of water here, but this time we have 55 grams of the solvent. We're looking for the water. So we find 80 degrees again, and 80 degrees at NaCl is 40. Okay, so this time X is 55 times 100 divided by 40, and we do the math there, you get 138 grams of H2O. Okay, so hopefully you get all this. We'll do some practice problems tomorrow, and then you can do your, well, classwork. So I guess I will see you tomorrow. Bye.